Hey guys, my name is Taylor Guevara and I was assigned to go over the Expert TA homework problem number 3, so I'll go ahead and jump right into that. So here you can see the graph that they give us for number 3. It actually has in the homework has different points like A, B, and C, but this question asks about D, so that's all I put on this paper because that's all that we need to be concerned about. So the first question for number 3, part A, is find the distance traveled in meters. So distance is how much ground is covered. So that is really just the total amount that we have traveled. So it doesn't matter what direction we've gone in or if we've backtracked. So as you can see, this starts at spot 9. It goes backwards to spot 3. So when we go from 9 to 3, that's an increment of 6. Even though it's going in the negative direction, we're only concerned about how far it's gone. So we're just going to call it 6. And then it goes from 3 to 5. Even though it's in the positive direction, we're just going to keep it regular 2, regular 6. So 2 plus 6 equals 8, which is the answer to A. For part B, it says find the magnitude of the displacement from start to finish in meters. So displacement is how far out of place an object is, and that's how far it is from the starting point. But the kicker in this question is magnitude. So magnitude is the size of displacement without regard to its direction. So magnitude is always going to be positive. So when we look at displacement, how far out of place the object is, we started at 9, and we end up at 5. That arrow is our kind of ending point for this part. So the difference between 9 to 5 is -4. But since it's magnitude, it is going to be the positive. So the answer is just going to be just 4 meters by itself. And then part C, find the displacement from start to finish. So displacement, again, how far out of place an object is from its starting point. It doesn't say anything about magnitude, and displacement can be either positive or negative. So we look at our starting point, positive 9. We go down to positive 5, but that's a difference since we're traveling left in the negative direction of -4. So since it doesn't say magnitude in the problem, the answer is just going to be -4 meters. So I hope that kind of helped explain things for you guys. I know it was a little confusing in the problem because I was thinking that when the way it was drawn on the computer, it kind of looked like it ended at 4, but it actually ends at 5. So that may have been something that you kind of struggled with. I know it's something I got confused with. And then also just that big word magnitude is something that is easy to trip up over because we just want to see displacement and just figure out what the displacement is, but we need to remember that magnitude, it doesn't matter what direction you went, it's just the total amount of ground from where you started at, between where you started and where you finished at. So those are a couple of things that may be a little bit confusing. This problem is really good about just kind of going over the definitions of displacement and distance and magnitude. So it is pretty important, I think, for the foundations of physics and what we're going to learn later on further into the semester. So I think this was a pretty good simple problem to just kind of reiterate those definitions and help you practice them in more of a real life problem or real circumstances. So I hope that helped you guys out, and thank you for watching.